Okay, so this is an iGCSE introduction into light waves. It's topic 3D. So we've got key maths in this topic of all the electromagnetic waves travel at the speed of light. So light will be 3 times 10 to the 8 in its velocity in a vacuum. It will slow down though in a medium. So although we use C equals F lambda, we've got something called the refractive index of a substance found for the ratio of the sines of the angles of incidence, angle of refraction. If you want to look into it, please do. But at GCSE, we just do the formula. A level, we'll look at the derivation, which is dead clever math. So N, this number, refractive index, is sine A over sine R. So if I have on this diagram here, I've got I and R. I do it on my calculator in degrees, and I get a number. This number typically for a prism would be 1.5. For a diamond, it would be like 2.4. So it's a number greater than 1, but usually it would be less than about 2.5. So you know if you've gone wrong in the exam. You also know if you get the angles upside down, you'll get like 0.7 or something instead of 1.5. You must get your angles the right way around, otherwise it doesn't work. Now there's something else, the formula for the critical angle, which is sine critical angle is 1 over n. We've got this really strange situation where if you look at my pictures at the bottom, we've got an incident ray coming in at an angle, and when we're less than something called the critical angle, the ray will be refracted out the back. But as I increase the critical angle, the angle to the critical angle, or I gets bigger, you can see how the angle's moved across, it's got wider. The refracted ray will graze along the edge of the boundary between the prism and the air. That is when the formula, this one, simplifies to this. So if I know what the critical angle is, I can work out n for the prism. If you go above that angle, greater than the critical angle here, then we're going to reflect the ray back outside on this side, and we call that total internal reflection. Now, total internal reflection is a concept used in optical fibers called TIR, and we can pass light down a fiber, and it will take information cheaply on scale, and it's used quite a lot nowadays. Refractive index and color, we should know that visible light will all split into a spectrum, and it will be dispersed effectively because each of the different wavelengths interacts differently with the medium. So violet will always be refracted more, so you'll get an angular spread. Still need to do the law of reflection, which we looked at before. And like we said, we've got to be able to measure refractive index. We've got to be able to do methods that give a pair of angles, so like this one, and a pair of angles here to work out the refractive index of a prism. You've got to be able to write a lengthy practical to do it. So there we go, 3D light waves introduced.